Good morning, everybody. Today we're going to do a quick explanation of how the Toyota EGR vacuum modulator works and how it commonly fails. So if you have a Toyota from the 80s on up to the late 90s, you will most likely have this EGR vacuum modulator. Remember, this is not the EGR valve, but this is what modulates or controls how much the valve lifts, the actual EGR valve. So these can fail, and you'll get the on OBD1 code 71, which is EGR malfunction, and on OBD2 you'll get I don't know, whatever the code is for EGR, insufficient flow. Same thing. Anyway, the most important thing to remember about the EGR vacuum modulator is that it is activated by exhaust back pressure, not vacuum. Down here, this port receives exhaust back pressure, not vacuum, but actual exhaust pressure. So positive pressure. You know how what comes out of your tailpipe? Well, there's a pipe connected to your exhaust, and when the engine receives enough positive back pressure, the gases move up this tube, up, and move a diaphragm inside of here. When this diaphragm moves, it allows vacuum into the EGR valve. So once exhaust pressure comes up, it allows vacuum to come from these two ports. This is the vacuum source, and then out this way. So this is input. This is output. This is control. So once exhaust back pressure comes up through here, moves the diaphragm up, and it allows vacuum to come from here and out to your EGR valve. Now, of course, it comes out the EGR valve and then goes to a vacuum switching valve, which is computer controlled. That's an on-off valve. So you don't get EGR during startups where you don't want it, or when the engine is cold. So once it passes that VSV, vacuum switching valve, then it goes to your EGR valve to do the EGR, to function the EGR. Anyway, over here, vacuum comes from two sources on the throttle body based on when you how much throttle you're opening. So when the throttle plate is closed like that, you don't get any vacuum. When you move it forward, it opens, I think, port P, and when you open it even more, it opens port R, and that allows the vacuum to go through, assuming the throttle is open like that, and assuming you're getting back pressure here. Anyway, how does it pass the vacuum from these two ports out to your EGR valve? Well, I said, positive back pressure allows vacuum, but how does it allow it? Well, we'll take it apart, and you can see inside is a diaphragm. So you take that off. Normally there's a little fuzzy air filter in there. That's what it looks like inside. And you'll see in a moment how the vacuum gets from here out to there. Now, if you look at it from here, you might think that, hey, it can get vacuum. Vacuum comes in, goes out this tube, and goes right out. What's the issue, right? It should always have vacuum, but it doesn't. If we take this out and look underneath, by the way, this is where your exhaust comes in. It just comes in through that hole. Then if we take this piece here and flip it over, we'll see how it works. Okay, if you look here, on this one line here, this top one, it's in, then it tees off. That's the trick. Then it comes out. So it's a T. It's really a T on this main vacuum line. So what happens is, normally the vacuum is just bled off, drained. You have a vacuum leak essentially through this hole because it's teed off. The only way vacuum can pass from this side out to this side is if this hole is plugged momentarily. And that's where your diaphragm comes in. That's how it works. Once this diaphragm sits in here, and you can see where it seats. And when you get exhaust back pressure, this diaphragm pushes up and the rubber seals this hole. Now vacuum can pass from this side. This is sealed now, so now it can pass out. And that's how you get it. So when you hit the gas pedal and you get exhaust back pressure, this pushes up. Remember, through this port, exhaust goes through here, pushes this diaphragm up, which then seals this T here and allows vacuum to pass through. That make sense? So that's how you get the vacuum to go to the EGR valve. But there's and of course there's a return spring that returns it, at normal diaphragm setup. So anyway, what's the second vacuum tube do? So we already explained this one. This is the T that I just showed you. Okay, this one. But what's this top one do? Well, this is an extra one. In case you don't have enough exhaust back pressure, this second port, which I just flipped it over, which is right here now, the second one has a hole here. So when you have your throttle open wider, like that, it opens another vacuum port on the throttle body, which then sends extra vacuum into this hole, into this port, to then suck up the diaphragm, regardless of if you have back pressure or not. So in other words, if you're in a situation where you need EGR, but the exhaust back pressure isn't enough to push up on the diaphragm, this vacuum port via the throttle body will open and pull the diaphragm up. So this allows the modulator to pass vacuum in a condition where you don't have enough positive exhaust back pressure to move the diaphragm on its own, and you need to and instead it will pull it up. Make sense? So normally this will push up the diaphragm and allow vacuum, but under certain conditions you don't get enough back pressure to do that, and then it would need to pull it up. I know it's a crazy system, but it works. Now, what condition would it need? Would you need for it to pull it up? Well, let's say you are in high revs, and you're not high, but because all this happens under 4 gram. But let's say you're racing the engine slightly, and you're not making enough exhaust back pressure, but you still need EGR under that condition, so it'll pull up the diaphragm. So anyway, that's a crazy system. That's how it's working. Anyway, let's go over how they can fail real quick, and I'll show you. This one failed, as you can see here, by making a hole right in the center where it seals. Now that doesn't look like much, but see how I can move that? I'll hold it up to the light. Okay, if I hold it up to the light, see that crescent-shaped hole in the middle? That's all it takes. That's a vacuum leak. I know you're thinking, oh, that's not much of a hole, but that's all it takes. It's like having a hole in your tire. It's not going to work. Let's see. You see that crescent-shaped hole in the middle? So all it takes is a tiny little hole, and then this doesn't seal. I know that doesn't look like a hole, but trust me, that's like a ripped open flap. See? It's a hole. So when that tries to seal on this T connection here, it doesn't seal, and the vacuum bleeds off, and you won't get EGR flow. And then you'll throw a code. How does it throw a code, you might ask? Well, there's an EGR temperature sensor on these cars, believe it or not. Even though they're old, they have an EGR temp sensor. And when the computer when the computer has the conditions to call for EGR, simultaneously it reads the exhaust gas temperature, the EGR temp. So if the exhaust gas is too high when it's calling for EGR, the computer assumes the EGR valve is stuck closed, or not opening, let's say, or not functioning, let's say. So it throws the code. So when the computer says EGR is possible and the temperature on the EGR temp is too high, then it assumes that the EGR is not working. So the typical culprit are a failed modulator and a failed VSV, that vacuum switching valve. These diaphragms are rubber and they can break. This is an aftermarket one which is made out of cheaper rubber, which is why it broke. And it's best to replace this with a genuine Toyota part, which costs a little bit over $100, but it's worth it because it'll last you, 100,000 miles forever. So anyway, this video should help clear up how this gizmo works. It's kind of weird, it's kind of old school, but they're on a lot of Toyotas.